Hey everybody, this is Larry. This is me going Q4 of the weekly contest 303, number of excellent pairs. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this poem. So this one, I'm just gonna go over my journey a little bit. You could feel free to skip ahead or 2x or whatever if you want to figure out this one. That took a long time. I did the first 3Q very quickly, but or at least relatively, but I didn't. The Q4 really destroyed my rating, as you can see here. So was or my ranking and also my rating, I suppose. Yeah, and one thing that I think, is that I have a bias, meaning that whenever I see these or and nums and bitwise operations, one of my inclination is to use a try. Also, I forgot to mention this. And you can watch me solve it live in the contest next, but after the explanation, but I actually did misread this poem. I thought it was the number of set bits in either this or this, not the sum of these two things. So as a result, I was like, oh, if you only worry about the set bits in either this number or this number, well, you only have to worry about. Oh, sorry. How I misread was that I misread this as the number of. I missed the word sum. So what I thought it was saying is the number of set bits in either this and this, in both of these things, have to be greater than or equal to k. And for that, I was like, oh yeah, that's the reduction. And the reduction is that we just have to do the end part, because why do we have to do the end part? Because the or part doesn't matter, right? Because the end thing is going to have fewer k than the org thing, so this is going to be the real constraint. I just thought, oh, this is how like they obfuscate the problem, they make it confusing, but it really just is this. And as a result of that, I was like, okay, then it must be a try problem, because maybe there's some things I could do with try. And well, the TLDR is that I spent about I don't know how long I spent. You could kind of watch the video, but maybe like 20-30 minutes, like just misreading it. And I was trying to solve it. I was trying to figure out how to use a try to figure it out. I was maybe trying to figure out using dynamic programming, but I couldn't reduce the complexity and all these things. I actually, halfway through, and this is something that I always recommend for these problems where you have different, for bitwise operations, because it allows you to do it. And I did do it on my notepad. And what I did is that I'll draw it here, really. Yeah, and what I did is that I drew a truth table, right? So you have this like operation A and B, and then you have this basically A or B plus A and B, right? And you do it for each bit because in theory they're independent, right? And especially on this problem, we have sum, but so they're independent. So after I figured out that it was a sum, I drew it out to see visualization. And I did draw it out. I had this is equal to 0, 0, 1 is equal to 1, and then 1, 0 is equal to 1, and 1, 1, this is equal to 2, right? And I think this is something that if you have done enough program or competitive programming, sorry, you might not, or you might have seen this already. Because afterwards I vaguely remember this, but I didn't during the contest. Also, yeah, and that's basically the key to this problem. Why? Because it actually took me a long time, because I wrote it out, but I was still trying to figure out how to use DP or doing bit by bit, and figure out like, the dynamic programming solution might be something like, okay, if this bit is 0, then you do this other thing on the rest of the bits, etc., right? But I couldn't reduce the complexity. Yeah, and basically the problem here now then is, yeah, and it took me a while until I finally looked at this and I go, oh, at a certain point, I figure the contribution of A is independent of contribution of B, right? Meaning that if we have the sum that, now we have bit by bit, but let's say we have all these bits put together. So you have like A sub I and B sub I, dot, 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 right? That means that you can actually separate them, right? Meaning that for A, if it is 1, the contribution to this f of AB is equal to, yeah, if A is equal to, basically it's just equal to A, right? So the TRDR is that this function is literally just for 1 bit A plus B. And then because you're dealing with sums, you can just think about, okay, now I know that I could separate them now I can do lookups very quickly, because now it's just, okay, let's say A have X bits, then for this to be greater than or equal to K, we have to find out, just the summation of those bits. So yeah, so that's basically the idea behind this problem. The idea and the way to do it is to draw this truth table and then maybe figure it out. And some people with experience would have already done it, but I did not. And I took a long time. You could watch the video, but I took a long time just like trying to figure out how to do it this way. Yeah, because I was still, even given this truth table, I was still trying to figure out how to do DP or try or something like this. But it took me, and it just hits me. So a short question that you might have is, will this be on an interview? I don't think so, or at least not an on-site interview. I could see maybe some tougher online assessments. This could be a gotcha type problem, because there's really no, I don't know how, I mean, maybe there's some problem solving experience here, but there's no like algo and data structure really here. So is it or at least, like, you may get it on an interview, but would I consider it a good interview question? The answer is no, because it's just the premise of how much data you're getting about a candidate, and then the question is, if they get it, do I think they're a good problem solver? Maybe, right? The answer is, I don't know that I would go that far. Maybe this is me being biased and salty. You can maybe assume that, but I wouldn't necessarily think that. And then the other answer is, if they don't get it, does that mean that they're bad for the job? Maybe not, right? So I don't know. So that makes it like a dubious interview question for me. So yeah. Anyway, let's go over this. Given this formula, I just literally do a bit count and then lookup, right? So for here, I do a bit count, and then here I do a suffix sum, so that now counts of K contains the number of numbers with K or more bits, right? So that's basically what the suffix sum is. And then here I just do a count on the suffix sum. So we have K we have this thing for a particular number. We need K minus X for the rest of it. And of course you have to go to 0. This actually cost me a 5-minute, because at that point, when I finally realized, I did it so quickly that I kind of got sloppy on this and ate a 5-minute penalty, because this was a negative number. Probably should have tested it, to be honest, but I was, like I said, I was rushing it. By the time that I saw it, I was like, oh yeah, this is so silly, because I was so far behind, as you can see. Yeah. And this is going to be, what is the time complexity, right? Well, this is just going to be linear time, linear space. Maybe you could say times this function is O of log n for some n, and here for 10 to the 5th is going to be like 20 or less than 20, like 15 or 16 or something like this. So then this is just 16 times n. You could say L time linear or whatever, but pseudo polynomial, if you will. But yeah, but it's going to be linear-ish in time, and in terms of space, this is just literally O of 64, right? So yeah, that's all I have for this one. This is a very sad problem for me, for obvious reasons of it's a lot of either you see it or you don't. Well, it took me a long time to grind, so I am happy that I grinded out, because I clearly did not see it immediately, but I did have a structure that allowed me to finally see it. But this was still kind of, I guess a lot of people did see it this time. So let me know how you did on this problem. Let me know how you destroyed me in this contest. And yeah, you could watch me struggle, and also me trying to solve the wrong problem for the first like half an hour or so. Now, come on. Okay, good. Oh, wait a minute. Wow, people already finished. Both no. What's an excellent pair? Did people finish already? Really? Well, maybe I shouldn't have refreshed, but okay. Just try to get a sneak peek on the. Oh, there's no 10-minute rank. Existing in one nums, okay. There's sum of the number of set bits in n are greater than k. So okay. Inquiry. Okay. So the or is a misnomer anyway. We don't care about the or. We only care about the and. So is this just a try problem? Well, case hack 60 makes sense. How do I think about this? Oh, it has to be unique, right? I wish they did one example of this, because this thing is a little bit weird way of putting it. Because in this case we have dupes on one. Okay, so we have to care about n versus k. Okay. Let's see. Do one. Do I do a DP on the bits? And it's prefix of. Yeah, I think this is a try question. I mean, I don't think it's that bad, but I have to do it. I think I know how to do it. It's just writing it will take a while. Okay, because then it's just about okay. Maybe I should have a better try question. But okay. For x and numbers, we want to say add x. We want to set. So then okay. Maybe something like this. I'm stalling. Focus. Okay, so then we'll do 60. No, 60 doesn't. Oh wait, no, it doesn't make sense. The 60 is silly. But we can do it anyway, I guess. Okay. Yeah, why not? Well, we can fix it later. Let's see, right? So I'm worried about writing a different class. That's why I'm like a little bit weird right now, but fine. I need to optimize this at some point, but I'll just write it. Okay, so then now, yeah, we'll do it backwards, I guess. Yeah, do we count? Okay, let's see, right? So what we want to do is this even right? Or I want to go left and then go right. Maybe I'm doing something funky. Well, people got it like very quickly, so maybe it's a standard problem. Because I'm trying to think, because if it's a 1, go to right and then 29 and then left. I mean, I think there's so many ways to do it, but I'm just like thinking about how to do it in a good way. Because you can pre-cache how many of each thing there is, and it'll be like 60 square or something like that. Because for each node, maybe, but this is going to be like a lot of nodes. Slow down, think. Maybe this isn't as easy as I think it is. So a lot of people got it very quickly, so maybe it's a known problem, but not for me. The recurrence would be just going. Okay, this is a 1. Okay, we put out the try, and then what? Right? Oh, this is N. Oh, damn. I messed up. I thought it was or for some reason. Okay. Then now, yeah, okay. This makes sense then. Whoops. I confused myself for a second. So now if it's N, then you just count. Do you? Well, if we go recursively going the other way, now you still have to go if it's 0, and then you use 1. Right? Okay. So how do you factor in all the other ones? Do you do recursion? Wait, I'm thinking about ones, right? But then we're trying to figure out how many zeros that we can take, and okay, 1 divergence. Okay, maybe that's how you do a count on. No, that's not quite right either, is it? because then now you cut it off at whatever. And the try is definitely right, but how do I use that try? I guess that's the question, and that's how people got it so quickly. Let's see. Basically, let's say we need 5, right? And this one has 5. So then now, try to figure out the numbers. How do you split up this thing? Where's the one to the other branching? How do you do the other branching without doing a lot more work? So okay, so let's say this is 0. Then it doesn't matter, right? Okay. Let's say this is a 1 though. I have to figure out we want to flip it off. And I don't know that I can, if it's some like DP thing. Because you have 32, choose whatever is going to be too slow. Yeah, people. If it's exactly, can I figure out if it's exactly? Also, I think my thing about ordering is a little bit weird, but actually, I misread this. If it's distinct, then maybe we can just build the entire tree and then use DP. Yeah, oh snap, I think I misread this problem then. Maybe. Because then now, it could be each node. There are a lot of possible nodes though, right? And then times 60 is a little bit expensive, possibly. Yeah, how do I do it? 60 times. I wish they made the bounds a little bit smaller, because 6 million is probably doable in some languages, but maybe not this one. A lot of people got it. Okay, maybe this is a standard problem, but. This is one of those problems I'm not going to get in my. A lot of people got it. I was so fast on the first 3 too, but today not so much. Can I do it? I feel like it's going to time out, that's why. Alright, fine, let's, maybe not. That's YOLO. Okay. It's a Python like count number of bits thing. Right. Bit count. I guess I could do that here too, because if it's smaller, it will never be good enough. Okay, and then now we want a node, right? So we don't want to cache on this. What we want is, how do I? Maybe I don't do it this way. Maybe this way is dumb. How do you look at the other side though? And then be like, because that's not. Yikes! Maybe I just don't know this one. Apparently people do though. Focus, focus. So you want to end. We do a bit at a time. So we use. Greater than or equal to k. Greater than or equal to k. Did I misread this? Maybe I misread this. Oh, I did misread this. It's this and this. So you have to sum it up. Oh wow, I misread this problem. Wow. I thought it was one of the. Oh wow, okay. Maybe I have to think about it again then. Okay, let me think. Refresh, misread again. Okay. So then now, let's say you have 1 bit, right? So, okay, focus. The end. So now bit at a time. If it's 1, you take k minus 1, sure. And then you go down 1 anyway. If it's n, then you do the other side. Does that really make sense any better? That's why k has to be 60. Oh, but let's say we have to try build. Oh, so this is wrong then. Okay. Goes to OR part. Can we do the OR part using? For each number, we can pre-process it, I suppose. Is it a try? I mean, you still need to do the end part, which is the hard part for me. A or B plus A and B. What does that mean? Okay, so let's look at the truth table. One is equal to 1. 1 0 is also equal to 1. 1 1 is when it's equal to 3. Oh no, it's equal to 2. No, it's equal to 3. Yeah. So it's either 1, 1 or 3. What does that mean? Wow, I misread this problem altogether. This is yikes. Let's say with an A we go by, right? I don't get it. How do you do the search? So every number in itself can count. I actually didn't even read this example. Now that I read it, it's a little bit silly. So then, okay, maybe I could do the inverse. Let's say I have number 3. How many numbers does it take to make it so that it's not, right? I just don't know this one, well. Wait, did I do this wrong? 1 or 1 plus 1, and 1 is 2. Whoops. Okay. So do we only have to do the OR? Maybe that's what I messed up with. Because the OR is 2. Because the AND doesn't really for a bit. Right. Is it TP? No, it's TP. Or maybe it's TP. And I had a typo on my thing, actually, on my handwritten notes. Let's say K is 3. And can we do exactly? We can do exactly and then do an N and or. This isn't the maximum one. That would be weird. Is that almost certainly a try? I'm not getting it. People are very smart today. I am not. Okay, let's see. So the 3, let's say we have a 3. Right, so we have a 1, 1. You have a try, that's 1 and 1. Right. How do we look at? Oh, this already has length 2 for the OR. For the AND, we don't get it. Wow. Props to people. I just, in 2 minutes too, or whatever. Today's just one of those days. Focus. What does k equal 3 mean to me? For each number, the bits will be whatever, but then the or I don't think I can. Am I just being silly? I don't get it. Not without some kind of brute force weirdness. Right, so okay, let's just write it out first. So that's the thing, right? Is that we have to go the rest of this way. So how would you do it? So let's say you have a 1, what happens? Well, if you have a 1, then I guess it's just an array of 60 elements or something like that, and then just keep track as we go. Does that even make sense? No, because you have to know the specific ones, right? That is so weird. Because you can, how do you even merge to same thing? So in the beginning we have you have to know exactly how many of okay. Because for all the numbers I think maybe it isn't try. Maybe I was stuck on try, but let's just keep it here for now. But let's see. Here maybe okay, now what? So for this number, how many numbers do we match? Well, also we have to do for a set. How many numbers do we match? Well, let's see, right? So 60 times 60 is definitely too much though, or 32 times 32 even for each number. That's a tricky part as well. then oh, I see, maybe. Because for this number, maybe, I don't even know that's true. If this is an or, what happens? Is this even, I don't know anymore. So if this is a 1, what happens? Then k subtracts by 1, sure. I don't know. Is it a try? So look at every number, every set number we. Maybe that is the way to go. The try. I think I confused myself with the exponentialism. That's why. But in the worst case, it's each node times 32. Maybe that's fine. And I have trouble figuring this out. Is there an XOR thing that I can do now? As well, this is the operation for each bit by bit. That's so hard. What am I doing wrong? Wah, 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 wah. So let's say they're all. Wow, a lot of people got it. I don't know what. Ah! Did I confuse this? The sum of the number of set bits. Okay, no, I think I actually read it correctly this time. Though total mind freeze today. Do it bit by bit. Maybe I'm just stuck on this bit by bit thing. Is there anything else I can do smarter about? Because how do I even do like break it down? Can I even break it down? I don't think try is the way though. Or maybe it is. No, you still need to do the number. Wow. Grind it out, 40 minutes left. At least make it not embarrassing. Okay, let's say we do it that way. Right. No, because that's just a try. I'm still doing the same thing with brute force. Whew. I don't even have an idea. Jeez. Okay, let's try something dumb then. What's the bit count? I mean, okay, so that works, obviously, but then that's obviously also too slow. So the idea is is there a way I can figure out how to understand this a little bit better? Okay, 995, that sounds right. Wait, what? Is that right though? Why would it not be 1 1? Is that right? Oh yeah, 3 times 3 is 9. Okay. 2 is 9. 5 is too many, but 1 is, can I look at each contribution of each bit? This is not helpful at all. But okay, so let's say we have a DUI. We know that it contributes 2 bits already. So then for k is equal to, what was the name? K is equal to DUI, we need to find a number which has at least 1 n bit with it. I mean, this one is using a DUI is not a great example though. Let's say we have 1 0 then, right? It has 1 bit, so then now we have to find numbers in which it has to make 2, but because that's not possible, that's just such. But even in the other case of, okay, let's just find bits in which we share 1 bit. How do you do it in an effective way? Or what if you need 2 bits? Right, like in the 4 case. And how do you 10 to the 5th, there's no pigeonhole anything. I mean, even if I get this is a disaster now, but I'm still not getting it, which is still even more of a disaster. Let's say for 3, I mean, we had some weird code before. Okay, let's say we have 3. 1 bit, 2 bits, so now we have to find k bits in the OR. The OR is also weird because you want to find unique ones. So, okay, so what does this mean? Let's say we have A. And there's 0, 0, 1, then here. So the OR bit, what is that? That means that the B oh geez, is that right? That would be pretty silly, right? And now I look at the function. I focus. Okay, I think I get it, but this is silly. I've had in my okay. Focus on solving it first. Okay. And then now. Right now, it's k minus this. Let's just do this time 64 just in case. Is that it? Okay, not quite that though. 15 and 9 is really wrong. Okay, so is this wrong? Now this 1 with 2 bits and 3 with 1 bit. Oh, I have to do set. That's why. 11 and 6. Okay, still not right, but getting there maybe. Basically here. 8 and 4 is definitely not right. So that's a little bit sad. 1 is 1. So you want something with 2 bits. Right. So is my... Oh, maybe I don't need this then. Maybe that's wrong. Oh, I do want this, but it's bigger, not smaller. So this is this plus 1. Okay, I get it now. That's why people are able to get it. This is a really hard problem. Already give me problem if well, that's unexpected. Did I submit it? Internal error. Come on. Okay, so I'm wrong. That's sad. So the correct answer is 12. Is it an implementation thing? My answer is 8. So we have 3. So it should be at least 5. So we have 5, and then just this should be enough. Oh, this is negative number, isn't it? That one is a silly one. Yeah, okay, fine. Okay. Yeah, thanks for watching. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this problem. And yeah, stay good, stay healthy, take good mental health. Take care and I'll see you later. Bye bye.